We are going live now.
We are live?
Yes,
Hello.
yes,
Okay.
we are live.
Okay.
Hello.
Hello. I warmly welcome
Hello.
you to our 43rd webinar by the Academy of Space Renaissance International. My name is Sabine Heinz and I am the person responsible for our webinar series. On this June 19, I'm really delighted that you have come to join us. We have people watching from Norway, he doesn't say the part where he's watching from. And today our special guest, Arthur Wood, CEO Astrostrom GmbH, and Andreas Vogler. He's a Swiss architect and director of the Andreas Vogler Studio. Hello, welcome.
Hi.
Hello. Our today's topic is
sorry, I'm sorry, Sabine. As always, there is an echo. Someone has an open window on the YouTube streaming.
Maybe Bernard or one of our guests. Hello, welcome. Some of you have a window open.
I think it was Arthur, because
okay.
I muted him and the echo stopped.
Ah, yeah. Okay. Okay. Our today's topic is greater Earth energy synergies. And I also would like to welcome our President, Bernard Foying. Hello and welcome.
Hello, so welcome from Strasbourg, where I am at present, so near the International Space Universities. But also, I was just following now a very interesting interview of Elon Musk on the French national television, as he was participating to the big high-tech fair, Vivatech, and he shared very interesting message about space exploration, about his rationale, and so on. So clearly, it's great to have Elon Musk on French territory. And it's also great to have our speakers, which I had the pleasure and the honor to meet in previous occasion. I remember that architect, and I would say space architect, Andreas Vogler. We have been a part of various moon-based design workshop. He was part of a Moon Life Academy event that we organized, also bridging between space architecture and also art and society. And of course, Arthur Woods was also very instrumental in the in bringing art and space together in various decades ago, and he has been also a very strong contributor to our Itacus Committee for Cultural Utilization of Space. But today we have found also another topic of common interest, which is developing sustainable energy from space. And clearly, what maybe was very speculative like 20 years ago, now is in the realm of being possible with evolution. For instance, the lower launch cost, like Elon Musk has allowed to, but also our advance in technology, in deploying possibly larger structures in space, but also in the evolution of the market. And so we are very much looking forward what our speakers are going to speak about. I have been also very interested in harvesting energy on the moon for the moon. And this is something where we have been also precursor in Europe, because we found places, peak of eternal light, where we would put bases and we could harvest in situ the solar energy. But they want to go even further, harvest solar energy and bring it back to Earth in a very effective way and sustainable way as well. It could be also an incentive for developing a space economy for large structures that could have a lot of synergies with other projects that we cherish at Space Renaissance, like developing an orbital facilities around Earth for many civilians and also in deep space. So welcome on behalf of Space Renaissance International.
Yeah, thank you, Bernard. And as you mentioned, Elon Musk, today I got an email from the IAF. This year IAC meeting will take place in Baku, and they announced the IAF World Space Award winners, and Elon Musk is to become an award or this award this year. And so congratulations to Elon Musk. We are really happy.
I'll convey your congratulations to him now that he's in France. Yes.
Yes, you can. You know.
If he stays for Le Bourget, where I'm going to Le Bourget, a famous air and space fair tomorrow morning. And so we'll see. We see a lot also of new space economy being featured there together with the latest news from space agencies and industry.
Okay. I also would like to welcome Adriano Ottino, our vice president, and he is our former president and one of the founders of Space Renaissance International. Welcome, Adriano.
Thank you very much, Sabine, and very welcome to our guests. And I want to just to add to the things that were already said about Arthur. Arthur is also a member of Space Renaissance International, and he is a long-time supporter of SRI from the very beginning, from 2008. And we were in touch even before, in the last quarter of the past century, because we developed together the concept of the Greater Earth and many other discoveries. We made the ethical manifesto of the Greater Earth that is still online on his website, Greater Earth. So yeah, we know each other since a long time, and we collaborated to the outreach of our concepts. Yeah.
Thank you. Before I give the floor to our speakers, I would like to introduce our guests to our audience. Asa Wood, CEO of the Astrostrom GmbH, is a Swiss independent researcher and astronautical artist with 2 art and space projects successfully flown on the Russian Mir space station. That was a cosmic dancer sculpture in 1993. And asked at Astra the first art exhibition in Earth orbit in 1995 during the Euromir 95 mission. His work has been exhibited in a number of international space and art exhibitions. He has co-managed several studies for the European Space Agency and the International Academy of Astronautics, of which is he is a full member and is a member of the IAA Permanent Committee on Space Solar Power. Currently, he is co-chair of the Moon Village Association Cultural Consideration Working Group, and he grew up in the vicinity of the Kennedy Space Center in Florida between 1959 and 1970, and worked at the Space Center in the summers of 1967 and 1968 during the Apollo program. So he is close involved with this topic. And Andreas Vogler is a Swiss architect and director of Andreas Vogler Studio. He worked in London, TU Munich, TU Delft, and as a guest professor at the Royal Academy of Fine Arts in Copenhagen, researching on prefabricated buildings, lightweight construction and space architecture. In 1999, he did parabolic test flights with NASA Houston, and in 2003, he co-founded Architecture and Vision, working in the fields of aerospace, art, and architecture. His studio work in architecture, transportation, design, and robotics. Space projects include habitats and manned rovers for Moon and Mars, as well as inflatables. Bernard, it's something very interesting for you, as you want to move to the Moon. His works are included in the permanent collection of the Museum of Modern Art, the MoMA in New York, and the Museum of Science and Industry in Chicago. So, Arthur and Andreas, the floor is yours. You may share your screen. Arthur will start, and afterwards, Andreas will talk a little bit.
Minutes. Thank you.
Yes. Okay. So we are really happy to have you here. So, Arthur, you can share your screen and unmute yourself. The floor is yours. You may share your screen. Arthur will start, and afterwards, Andreas will talk a little bit.
Minutes. Thank you.
Yes. Okay. So we are really happy to have you here. So, Arthur, you can share your screen and unmute yourself.
I'm sharing the screen. Could you not see it?
Yes, you have an echo inside. Maybe you have another window open. You may share your screen. Arthur will start, and you see? Afterwards,
you had
another
an
device.
Through the presentation,
Yes.
there was an echo.
Okay. So we are really happy to have you here. So, Arthur, you can share your screen and unmute yourself.
I'm sharing the screen. Could you not see it?
Yes, you have an echo inside. Maybe you have another window open. You may share your screen. Arthur will start, and you see? Afterwards,
you had
another
an
device.
Through the presentation,
Yes.
there was an echo.
Okay. So we are really happy to have you here.
Whoops.
Now it's good.
Yeah, we see the screen.
Can you see the screen? Okay, good.
Yes, we see the screen well.
Okay, I'm very sorry. I had my browser was open, so for some reason it was causing a problem. So is everything okay now? You hear me fine?
Yes.
Yes, we can hear you fine, and we
Okay,
can
fine.
see the.
Okay.
Maybe
Well,
you
thank
can
you very
make it
much
full
for
screen.
the
Maybe you can
present-
put it on full screen.
It is full screen. It's perfect. Go ahead.
Okay, good. So thank you very much for the introduction and for the opportunity to be here. I'm sorry I had to echo the whole time, so I don't know what anybody said, but I'm sure you said very nice things. Yes, I go back a long time with Space Renaissance. I've been a member for quite some time. And today, the topic of our presentation is called Greater Earth Energy Synergies. And basically, this is a report, the first public report about the study we just completed for the European Space Agency, and it's called the Greater Earth Lunar Power Station. Now, the four main people in this study was myself, Andreas, Patrick Collins, who is, unfortunately, it's 3 o'clock in the morning for him, so he couldn't join us here. He's a professor emeritus at Ashaba University in Japan. He has a PhD in space solar power, and he teaches economics, and he's a world authority on space tourism. And Dimitris Kasparovak is our animator. We're going to show quite a few videos tonight. So he's the guy who's the genius behind all of those. And I should mention one other person. When we made the proposal to ESA, my longtime colleague was Marco Bernasconi, and he had to drop out in the middle of the study due to health reasons, and that's unfortunate. So the Greater Earth Lunar Power Station is a concept about building solar power satellites, mostly from lunar materials, and these will be robotically assembled in Earth and lunar orbit. Just a little information about the term Greater Earth and the symbol. I use a symbol, the circle with a cross in it, which is the Greek astronomical symbol for planet Earth, and GE plus the symbol is the symbolic logo of Greater Earth. Now, Greater Earth is a new perception of our planet that's based on Earth's true cosmic dimensions as defined by the laws of physics and celestial mechanics. It's also a dynamic, interconnected, interactive, biological and geophysical system that for billions of years has led to the appearance, evolution, and maintenance of our living planet. The first mention of the term Greater Earth was in Space News back in 1994 by Eliza and Kevin Griffin, and they wrote an article called "It's Greater Earth Stupid." After that article was published, a group of us got together online, and we had an online discussion for a couple of years, and we came up with the Greater Earth Manifesto, and Adriano was a member of that group, along with Stefan Stephen Ashworth, Marco Bernasconi, Daniel Christline, Michael Martin Smith, and myself. So that we've kept the name alive over the years, and that's why we have this new project here. Now, just a little information about the concept of greater Earth. Actually, it's defined by this gravitational influence where it interacts with the influence of the sun. It creates a sphere that is 3 million kilometers in diameter. Inside that sphere passes 55,000 times more solar energy than falls on the surface of Earth. And actually, you could put 13 million Earths inside that sphere. It also contains the moon and occasional passing asteroids. And the outer borders of greater Earth are marked by the Lagrange points 1 and Lagrange point 2. At L1, we have the Discover Deep Space Climate Observations Observatory, and its EPIC camera that takes a photo of the Earth about every 30 minutes, and it's studying the climate on Earth. And at L2, we have the James Webb Telescope, which is looking out into the cosmos. So the region of greater Earth is pretty well defined, also by our own technology. Well, as I said, the moon is an essential part of greater Earth, and the surface area of the moon is 37,936,694 square kilometers. And it's slightly bigger than the surface area of the African continent. So we could actually call the moon the 8th continent. And just recently, we ran across this document here, is that back in 2003, ESA did a study called Moon, the 8th Continent. And I believe Bernhard was an expert consultant on that study. Yeah, and it's very interesting because some of the ideas that they put out was to develop a clear vision and realistic implementation for planning European human spaceflight. And the main brief was to support key stakeholders and decision makers. And at that time, this was in 2003, they go by 2025, Europe will begin to operate permanently a manned outpost on the moon. And also, a purpose of this is to help address the global challenges of the future. It seems exactly where we are today. Well, actually, they had on page 41 of this document, they talk about some of the economic elements of a moon base. And they did mention way back then that there have been suggestions that solar power plants built on the moon could provide a clean, reliable source of renewable energy for our planet. And these solar power plants could collect a small fraction of the moon's dependable sunlight, convert it into microwave beams that will be sent to receivers on Earth. So it's amazing that this idea has already been around for 20 years. Well, just to add a cultural dimension to this, there's a very interesting book called The Next Continent, written by the Japanese Isu Ogawa. And it's a fascinating book about a private mission to the moon as one woman's destiny. And so actually it's quite an interesting business case for going to the moon. So I suggest everybody read this book if they get the chance. Well, now we're talking about why go to the moon. I mean, there's a lot of missions around to go to the moon, and we know Artemis is planning to go there, but really, why do we want to go? What's the real purpose? And many years ago, Kraft Erica said, if God wanted to become a spacefaring species, he would have given man a moon. So in 2021, the European Space Agency made a call for ideas. Clean energy, new ideas for solar power from space. And we submitted a project called the Greater Earth Lunar Power Station. And this is an idea of a power station that has a habitat. So it had two aspects to it. And 85 proposals were sent to ESA, and they selected 13 of these, and they funded 13 of these proposals for future development and studies. And so we were lucky to be one of those. So we actually had 2 business cases already built into our proposal. We had 2 economic drivers, and one was tourism. We see tourism as a very big economic driver for lunar development. And the other one, of course, has to do with energy. Now, I'm not going to talk about the climate emergency because everybody's talking about it. Yesterday, Switzerland voted to back the EU's 2050 agenda, but the energy dilemma is something that's come up very recently because of this energy security issues in Europe, especially. And actually, we think, why would we have energy from space? Well, basically, Earth's energy reserves are finite and inadequate for sustaining civilization, and the terrestrial energy options that are around today, in our opinion, cannot be sufficiently scaled to meet humanity's energy needs. Now, just to look at some of that, this is how much fossil fuel is left, and this was published in 2020, so the years are actually less than you see now. Actually, this is based on BP Statistical Review of World Energy, and it's actually only 49 years of gas, 54 years of oil, and 139 years of coal. Now, I know there's all kinds of technologies to extend this, but on the other hand, if we have such a finite amount of this valuable energy source, maybe we should not be using it for energy. And that's a very interesting point here. And so it also speaks to the climate issue. Well, this is an interesting graph here also from Our World in Data. And this shows you how the global primary energy consumption by source. And it really started in 1800 when we started using oil. But what happened around 1950, and I say 1957 because that was when Sputnik was launched, look how much energy humanity's used since this time. And so on the one hand, it shows you how much energy is being used because of all these things, but also maybe this amount of energy has helped to enable humanity become a spacefaring species. And so I find that a very interesting graph speaking to the future. So that's where we are today. And in the course of our study about last summer, ESA has decided to launch a program to further study space-based solar power. It's called Solaris. And they were quite impressed with some of the graphics and some of the animations that we've been doing for our study. So they asked us if we could make this video, which they use to promote the Solaris thing. And this was shown to the ministerial meeting last November, and I think it helped get Solaris funded. So I'm going to show this video. Should go.
The sun, the source of energy for life on Earth. Stored in fossil fuels, the sun's energy has powered modern civilization for over 200 years. But the use of fossil fuels has resulted in dangerous global warming and a changing climate, to the extent that the United Nations and the European Union have declared a climate emergency. Transitioning to clean energy is an urgent imperative, and Europe is committed to achieving net zero emissions by the year 2050. But this will be extremely difficult if we rely only on existing renewable and low-carbon energy solutions, as intermittency of supply, pressures on land use, scalability and toxic waste limit how quickly and effectively existing energy sources can be rolled out. The European Space Agency has been investigating a new solution that could overcome all these problems. Solar power delivered wirelessly from space to Earth. Europe has the technology lead in building and launching communication satellites. This deep know-how can be built upon to develop and scale up solar power satellites. Huge orbiting solar farms, built up of many similar parts that will be mass-produced, launched into space on low-cost, reusable launchers, and assembled together in orbit using advanced robotic techniques. Once completed, these satellites will collect the full power of the sun's energy 24 hours a day, 7 days a week, and beam it wirelessly down to Earth to receiver stations, which will turn it back into electricity and deliver it to the grid. Space-based solar power is thus a continuously available, inexhaustible, sustainable and scalable source of energy that could help Europe meet its climate and energy security goals. This is not science fiction. The fundamental technologies are understood and are already being demonstrated on Earth and in space today. However, there are still many engineering and policy challenges that would need to be overcome to make this ultimate energy source a reality as early as the next decade. Other nations are already working on realizing space-based solar power. If Europe also wants to benefit from this game-changing capability, accelerated investments in research and development would need to start now to determine if space-based solar power can indeed offer another source of affordable and abundant energy for our green future. And in doing so, launch a new European space energy industry that would provide enormous opportunities for innovation and economic growth in space and on Earth.
Just to see our credits at the end. So in the course of the past year, ESA also commissioned 2 cost versus benefit assessments about space solar power. These were carried out by the Fraser-Nash Consultancy in London Economics in the UK and by Roland Berger and OHB in Germany. And Fraser-Nash and London Economics looked at Ian Cash's Cassiopeia SPS concept, and Roland Berger and OHB, they looked at John Mankin's SPS Alpha Mark III concept. Well, the results of these studies is that both concepts are technically and economically feasible. Fraser-Nash indicated that a Cassiopeia at the 10th system, I mean, there would be 9 systems that get progressively less expensive, but at the 10th system would cost maybe about $7.6 billion. And they estimated 54 of these would cost $418 billion, and they would deliver 70 gigawatts of electricity. And actually, one of the Cassiopeia satellites at this dimension would have a launch mass of 2,491 metric tons. So if we multiply that by 54, we're looking at launching 134,514 metric tons into GEO. Now, the 54 solar power satellites would need, and I'll explain this later, between 4,644 and 6,426 Starship launches, just to give you the dimensions. Now, SPS Alpha is a larger system weighing 7,600 metric tons. So we would have a 25 of their systems would have a total mass of between 152 and 190,000 metric tons. 362 Starship launches per SPS, or 9,000 Starship launches for 25 SPSs. So we find this is a very important factor, which gives quite a bit of context to our study. Now, just to put this in context, since 1957, only about 20,000 metric tons have been launched into space, and most of this into low Earth orbit. And we have the opinion, or our study has shown us, that building SPS components from lunar materials could reduce the mass launch from Earth by up to 80%. And this would also mitigate the launch bottleneck, because all of those rockets, you can have a huge amount of logistical issues about launching so many rockets if you really want to be serious about space-based solar power. So this is where our study focuses on. So I'm going to show another little video here. It's kind of the overview of our study.
Welcome to the Greater Earth Lunar Power Station. We are going to the moon to build components for solar power satellites from lunar materials, which could help mitigate the launch bottleneck and the environmental impact of launching many solar power satellites from the surface of Earth. This is a multi-trillion euro opportunity which addresses the climate and energy crises on Earth. Can you think of a better reason to go to the moon?
Well, we've given a lot of thought to this, and we've developed a system architecture, which I think I'd let Andreas explain to you now. That's okay.
Yes, thank you, Asa. I can join in here. Yeah, basically, we studied what do we need to kind of install a manufacturing facilities to produce power satellites, and we looked at various studies done before us, like Gerard O'Neill's studies in the 70s. And as you know, they have been based on mass drivers, and they shoot material to L2, and then they ship it over to L1 to build up a space station. So we look deeply into that, and also the technology of mass drivers. But basically, we came up that a position at L1 to construct the SBS may be quite favorable because it's a more or less halfway stable position between the Earth-Moon system. And so let's start with the Moon. What we need, obviously, we need mining facilities. We need to process all the regolith, separate it, heat it, beneficiate it, to have raw material for fabrication. All should be done highly automated. Our current assumption is to have a crew of 3 people at L1 and a crew of 3 people on the Moon, basically just to troubleshoot if robots have problems. So we have this whole fabrication line. We install what we also have seen and will see in the videos, preliminary power to build all the parts we need to assemble the first solar power satellite. As soon as this is ready, we can project more power down to the Moon and accelerate the whole production. So, and then the idea is, after studying mass drivers and the technology needed for it, and did some trade-offs, we actually came to the conclusion that, although not researched really in depth yet, lunar space elevator may be a much more promising technology to establish, to deliver from lunar surface to L1 all the materials we need. And but also we need more. We need to set up a whole transportation system. We come back to that, for materials going to the Moon, but also from the Moon back into Earth's orbits, or some of the materials which we process may even go back down to Earth. So there has been discussion about helium-3 gaining, but we think as maybe a first accelerator of this whole system, maybe a propellant production, maybe a kickoff of the whole business. But anyway, we come back to the transportation system, which we kind of designed. Is a modular system, but the idea is we fabricate on the Moon. We use gravity as a friend, I would say, because all our manufacturing technologies on Earth are based on gravity. And we had this discussion: do we fabricate in zero gravity, or do we fabricate in under gravity conditions? And we found it more practical, helpful. There's more experience how to use gravity. You save 1 or 2 robot arms if you can use gravity. So kind of all this kind of hundreds of thoughts and discussions we had in the team, they led to this system architecture drafted up now. So we produce solar panels or hybrid solar panel antenna parts. which we assemble in L1. And for the satellite structure, we use basalt parts from the moon. And then as the satellites are assembled, they are transferred to geo orbit, where they basically can go into operation. An additional potential benefit of the space elevator is that we could extend the line near geo and even deliver all the way through to Earth. But this is subject to more studies of how actually the whole physical and engineering system of a lunar space elevator would work. And then I hand over to you again, Arthur.
Okay, thank you,
The next
Andreas.
video coming.
So more video, which is going to expand on the one we just showed you. It's called Here to Stay.
Our vision of arriving on the moon, deploying a mobile solar power system, commencing mining operations, and protecting the habitat from radiation. We are here to stay, and waiting for you to join us.
Well, as you saw, we used this SpaceX's human landing system, which they received a $2.9 billion contract back in 2022 for being a part of the Artemis mission. And we thought that's a pretty good idea. But in the meantime, actually just a month ago, Blue Origin also got a contract for a lunar lander, a $3.4 billion contract. And this should happen around 2029. Now, what's really different between these two is that the Starship, of course, uses liquid methane, and Blue Origin will use liquid hydrogen as one of its fuels. So that might be a very interesting development later on, because if we want to produce fuel propellant on the moon, then maybe it's easier to do it with liquid hydrogen and liquid oxygen than with methane. Well, that's very interesting. Anyway, what you saw us about burying the Starship, we said, well, we want an initial habitat on the moon, and so we thought we could just knock this thing over because it has a life support system in it already, and we could just use it. So the first rule of space architecture is to use what you have. And so we developed this idea about a year ago, but actually just in April this year, a group of researchers published a paper actually discussing the exact same concept, but they didn't use an inflatable. They used cables to lower their Starship down. So that's very interesting coincidence. And the mobile photovoltaic device, these would be sent up from Earth, and this would be using terrestrial technology and an inflatable system. And this would supply power for the initial operations on the moon, because we can't produce power right off the bat. So these systems would have a mass of about 100 kilograms. The rover is about 40 kilograms, and they can deliver about 12 kilowatts of energy to the moon. So we thought this is and these could be flown up from Earth in the initial missions. And now another key aspect here is, whoops, didn't go. Go back. Is it playing? Huh? There we go.
The Greater Earth Lunar Space Elevator, the core of the cislunar transportation system.
Well, highlights from this video is that we have a bigger rocket, and actually Europe definitely needs a reusable heavy lift launch system. And actually just A month ago, ESA placed 2 contracts, one with the Ariane Group and the other with the rocket factory in Augsburg to develop what they call the protein heavy lift launch system. So ESA is definitely on track to build its own reusable heavy lift launch system. And also the Ariane 6 is also being looked at if they can maybe make it partially reusable. Now, the lunar space elevator is a pretty exotic idea, but actually it can be built with existing materials today. We don't need exotic nanotechnology. Xylon and dynamo are 2 materials that can be mass produced that are strong enough to give the cable the necessary strength. And Charles Radley and Marshall Eubanks, we met with them in the course of the study, and they've written several papers about this lunar space elevator. And they actually have proposed that a 48-ton elevator could be built and packaged onto a single heavy lift launch system. So actually, this is a doable concept, and it's interesting that not too many people are looking at it, but we're looking at it very seriously because it's a key technology for us. And this is kind of a graph of our cislunar transportation system. As you see, it's quite modular. We have a low Earth cargo relay station. Also in geostationary orbit, we have our reusable rocket. We have the lunar elevator. And at the moon side, we have a lunar landing gantry. And in between, next to the elevator, we also have a cislunar cargo shuttle. So it's a very modular concept that also goes together. And if this would happen, what you're seeing is the Suez Canal between the Earth and the moon. It would be a fantastic transportation system. We'd have a huge impact like the Suez Canal or the Panama Canal has had on Earth. So here's another video. Whoops, I have a hard time getting it to start. There we go. Now we're going to look a little bit closer at the mining.
Mining the moon, beneficiation, processing, fabrication and transportation of the components for the Greater Earth Lunar Power Station.
So what you saw here is now in a schematic form. Andreas, you want to talk about these graphics?
Yeah, I may join in and maybe say something what you just have seen in the video quite good. Also approach it a little bit telling you about our all-over philosophy, how we approach this project. You have seen that we identified the NASA RACER robot as a pretty good kind of already quite developed mining robot for a lunar environment. And we also had a look at having big surface mining machines, like having a very big output and produce mass. But actually our approach is more like, let's work with very small entities, which we can scale up easily. And so we can produce an economy of scale, kind of employing industrial processes to the whole space world. So also one slide before with the transportation system, up to now, spaceflight has been A to B flying. You build a rocket for your mission, and then the rocket is cancelled and you fly from A to B and maybe back, but then that's it. But actually, if you modularize the whole system, you have a much more sustainable and probably resilient system, and you can scale it up at any time and where it's needed. And also in mining, that has been our philosophy. We scale up not by building bigger machines, but by adding more. The same with the factories, this kind of conceptual drawing of some factories you see here. We have been thinking how it could work to land a module which is maybe not more than 12 tons and maybe 15-meter wide and 450 diameter, and how you can establish kind of certain production technologies there. And today we have a variety of technologies which we can use: 3D printing, digital manufacturing. So we're looking at a regular sintering factory where we just can sinter different shapes, or a basalt casting factory is a technology already existing on Earth, that there are kind of tubes casted out of molten basalt. The same we can do on the moon. We just heat the regolith and we pour it into shapes and produce our shapes. Or the antenna factories, which we print on thin film technology. There are actually a couple of aspects where we tried also the idea of pull technology, which has to be said. So we not only have been looking at what technologies do we have today and what is the next step we can achieve, but we also discussed a lot about what would be the best technology maybe available in the future to do something. And this we have been trying to kind of translate into our videos. And the videos, they really should be an inspiration for engineers worldwide to join us in this endeavor of really starting a lunar economy. And what we have been penciling up is really just kind of the first draft, how a future lunar economy could look like. But we come back to that to the end. And Arthur, what's the next slide? I think you...
Yeah, okay. Now it's just going to be our last video of the night. But a pretty exciting one, I find.
Up and down the cislunar transportation system. Building the Greater Earth Lunar Power Station.
Well, that was our last video of the evening, and I hope you find it pretty nice. Anyway, we've identified 3 key technologies. Now, the first one is the photovoltaics on the moon. There's a technology called monograin layer solar cells. It's a single crystal type of solar cell that does not require wafer technology. To put silicone-based wafer solar cells on the moon is a very, very complicated procedure. And this does not need the high temperatures and the precision that, or at least the purity that normal solar cells. To build solar cells on Earth takes a really fantastic, a really large manufacturing system. Anyway, this technology is under developed in Estonia at the Tallinn Technical University, and also the technology is commercially available, not with lunar materials, but by Crystalsol GmbH in Vienna. They're actually producing this kind of technology right now commercially. But our ISDS on the moon, the material that's most interesting, the one that's being developed by Tallinn Technical University, is pyrite, lunar pyrite, which can be synthesized from lunar materials. And as mentioned before, lunar basalt is a very, very interesting thing. The technology is very old on Earth, and it can be adapted. There's quite a lot of basalt in the lunar regolith, and in Aachen University in Germany, they've actually developed a concept called moon fiber. And also this has been supported by ESA, as is the MGL solar set cell. It's being supported by ESA. And in their little trailer video, they show that they can produce 180 kilometers of basalt fiber per hour. And basalt fiber actually has quite a good tensile strength. So it could be a way to enhance the lunar space elevator, but it's good for so many other things, insulation, structures for our solar power satellite, etc. And the other key technology, of course, is the lunar space elevator. And as I mentioned before, this could be built today from existing technologies, and it would create this the core feature of the cislunar transportation system. So those are the 3 key technologies that we've identified, and they're all existing technologies already, or based on existing materials. Now, looking at the other side of the picture is the business case. And Bloomberg last year gave out a report that to reach the net zero goals of the European Union, it's an energy transition. It is a 5 trillion euro investment opportunity. Keep that 5 trillion in mind. So this is a look at the current energy consumption by fuel in Europe. And you see the breakdown right there and how much Europe uses. And down at the bottom, I've mentioned that today installed wind is 236 gigawatts and installed solar is 41 gigawatts and a total of 277 gigawatts. It's really roughly 11% of the overall energy consumption in Europe. Now we look at electricity because that's what we're really going to be interested in. And here's the breakdown today of how electricity production is distributed. You see nuclear at 22%. Fossil fuels are about the same today. And the International Energy Agency has done several reports, and in their Energy Outlook 2022, they had several scenarios for the future. The most conservative one is 75% increase in electricity production, all the way up to 150% in their net zero scenario. So that is the real big goal stated by the EU. So altogether, if you look at fossil fuels, hydroelectric, and nuclear, this equals 75% baseload power, and baseload power is what keeps our grid stable. Now, if we go to the next slide, we're looking to the future, and here we estimate 78 SPSs would supply 11% of the European electric market in 2050. Now, that 11% is exactly the amount of electricity that fossil fuels supplies today. So we thought as a goal, if space-based solar power could provide the same amount of electricity that nuclear provides today, this would be a realistic goal. And so that's it. But see the difference here. If we would even include space-based solar power in this scenario, we're only at 34% baseload power. So we have a deficit of about about 50% of baseload power, which is so essential for running society, especially if you want to electrify transportation, heating, etc. So we really need to have this baseload power. So 78 SPSs applying 11% to this would mean the following. And using the system that was described by Fraser-Nash, 78 SPS systems with a capacity of 144 gigawatts and an availability of 90% would give approximately 1.3 gigawatts of power. And this would require, if you take the Starship refueling system, this would require 6,708 Starship launches. And if you launch directly to GEO, which Starship is not, I mean, SpaceX is not really interested in doing it, I heard recently, this would require 9,282 launches. So for an equivalent lunar-based system, like I said, we could probably reduce the launch mass by 80%. 78 SPS systems would require 2,184 launches at 28 launches from Earth. And I think this is a high number. It could probably be a lot less, depending on whose opinion you're going to follow. And to install the manufacturing facilities in the moon, we've estimated would take about 467 launches for the infrastructure. So if you look at our two systems, and we're not in competition with Fraser-Nash, it's a comparison here. Our lunar power station would cost about 3.6 billion per SPS, and Fraser-Nash, because they have to launch so much mass from Earth, would be about 7.6 billion per SPS. But if you look at the development costs, and we're going to talk about our 99 billion in just a second, we have a break even after about 20 SPSs. So this is a breakdown of the levelized cost of electricity, which is a standard way of looking at energy production systems. And you see here on the cost side, we're launching that 20% is about 400 megatons, metric tons of SPS hardware to L1. The cost of that hardware would be about 120 million. And this is basically computer elements, the Eon drives we're going to need to stabilize this thing, wiring, and some other electronic stuff that we would need. That's included in this 400 metric tons. The launch, which is kind of a high cost, is 1.1 billion. On land, the Rectenna would be 1.5 billion. And we have a crew. We include that in the cost, 870 million. So actually, this 3.6 billion is the actual physical cost, but on top of that, we have the cost of financing, the money, and also operations and insurance and maintenance. And this 1.2 billion, this comes from the Fraser-Nash study. So it's an equivalent kind of thing. We deliver the same amount of power, but we do it at 74 megawatts per hour as a cost. So this is a very interesting thing. It's very competitive with anything on Earth today. And this is kind of a hypothetical revenue estimate based on selling the electricity at 15 cents per kilowatt hour. One SPS would have a gross profit of 23.3 billion. And over 30 years, that would be, net profit over 30 years of 17.7 billion. And that's very interesting for one SPS. Now, if we look a little bit further down the line, if we have our 78 SPSs out there, the net profit from 78 SPSs would be 1.4 trillion based on our figures. So what would it cost to do this? Well, our estimates for the initial infrastructure is an investment of 99 billion euros. Now, the top three numbers is 16 billion for SPS development. This is what has to happen anyway. This is a figure put out by Fraser-Nash. What it would take to build an Earth launch SPS system. So that's in our budget. 10 billion for the reusable heavy lift system, which ESA's already started on, but Ariane 6 cost more than 4.5 billion to develop. So we think a heavy lift reusable would be realistically around 10 billion. And the lunar space elevator, we've tagged it at 11 billion. Now, the mining operations that we've seen in the video, we think the 5,500 metric tons of material, this would cost 43 billion. We have LEO operations and human Q costs. And altogether, this comes to 99 billion. Now, this sounds like a whole lot of money, but you have to know that Artemis today has already cost $96 billion, and they don't really have a business case as far as I know. So anyway, in order to get this money together, we propose to create a Greater Earth Energy Organization. This would be a multinational group of stakeholders, mostly countries, that would manage their own energy resources and revenues. And we have a formula that's it's a population divided by the population divided by the per capita energy use, and it creates a prorated national contribution that is totally fair and equal to all of the countries. And the way this would happen is that in the first 2 years, starting right now, we would like to raise 10 million for this organization, and that would lead us to raise 100 million to set up the organization between 25 and 2026. And then once you have a group of these nations together, coming up with 10 billion a year should not be a problem, because we estimate maybe 20 or 30 nations would join into this. Now, that $99 billion is just 99 billion euros, excuse me, 99 is just 2% of the estimated 5 trillion investment of the European energy transition. And I think that's really a key point here in the business case. So this is our roadmap. Maybe I let Andreas talk about this.
Well, yes, actually, I don't want to go too deep into that. It's just like a preliminary plan how this could be set up with the demonstrators or the work done, which has to be done on Earth, building demonstrators at the beginning, testing, and at the end, building up rectennas. At LEO, we would start with orbital demonstrators, actually a kind of LEO cargo relay station with probably an equatorial orbit would be our first suggestion to do, because we could start using it as a demonstrating platform for not just for WPT, but also for robotic assembly. And the benefit of equatorial from Kourou, we could reach that station basically every 1.5 hours. So it would be very accessible. We could reach it with kind of medium-sized rockets. And then from there, with our modular system, have a transportation vehicle to L1 and down to the moon. So we will build up this. But basically, summarizing, the idea would be establishing the fabrication system on the moon, produce SPS, and as SPS starts, there's going to be more and more energy available on the moon, and we can accelerate over time the production ratio of SPS on the moon, and basically go on as far as we can, as far as we need energy, I would say.
And would you like to talk about this?
Yes. Yeah, maybe to put that together in kind of economy, some of you may know this kind of flywheel system. It has been used often in context with Amazon, how Amazon made their business so big, because I think most of you remember Amazon started in the 90s as selling books over the internet. Meanwhile, they're probably one of the biggest shops on the world. You basically can buy the whole universe. And why is that? Because they continuously invested into platform ideas. So once they had the platform for books, they kind of opened the platform for other sellers, and they kind of developed logistics. So, and then they opened their logistic system to others. They invested into cloud computing. So they make actually a lot of money with cloud computing because it was part of the business. And we have been kind of drafting up this flywheel diagram of a lunar economy, because we think that really could work if you start thinking with you build platforms. So the initial driver to start this lunar economy would be the energy market on Earth, which is multi-billion market, very big market, much bigger than today's space market. But by doing this, you would enable much more. By starting mining, you produce many materials, also oxygen and many other stuff, which allow habitats. They allow tourism, it allows sports. You open a platform for new startup businesses because the entry threshold is lower. By each piece we do in our concept, we lower the entry threshold to start a business idea in the cislunar space. And this is the flywheel idea. Once it starts slow, but once it's turning, it's hard to stop. And basically we have the L1 space harbor, which may be the place you go off to the moon and deep space exploration. And you really, this idea of delivering green baseload power to Earth from space, manufacture on the moon, may actually, the big side effect of it may be that you start a whole new cislunar economy, and you really, humankind will make the step into space for a non-reversible step into space, not like Apollo, which is 50 years ago. So I think this is the kind of our thinking, and I think also it's also the last slide for today.
Now we have one more slide.
Okay, so there's one more thing.
The last thing is, will our future be a Stone Age or a space age? And that's what we're talking about, because if we don't develop an adequate energy system, we're going to be really in dire straits in the future. However, we can look backwards and we can look forwards, but if human history teaches us one thing, it's this: fortune favors the bold. And I think we've presented quite a bold plan, and we would like to see it go forward. So thank you very much for your attention, and it was a pleasure to be here, and thank you for the opportunity.
Yeah, thank you so much for this interesting lecture. And it was very, very interesting and very well explained and made visible for our audience. I have a question. Maybe it is not. I'm not a physician and or physicist, so I don't fully understand how the energy comes to Earth. I mean, I'm not entirely clear on the wireless transportation. You know what I mean? So I know we can get the solar power here and transform it into energy.
Yes.
Yeah, but how you send this energy in a wireless way to Earth?
Yeah, I go ahead. Maybe I explain you quickly. It's basically a concept from the 1960s already by Peter Glaser, these space-based power satellites. And there are basically two ways you could transport the energy from space, from an orbit to Earth. One is laser. Laser probably it's not such a good idea, because if you have an airplane flying through the laser beam, it's probably not going to land. Or so laser may be interesting for other applications in space on the moon. But the other alternative discussed today is microwave technology. And that's fairly strongly discussed because, and usually the wavelengths of our Wi-Fi signals we have at home, that's also microwave. Some people may think microwave is only in the oven and you burn your fingers, but actually our whole communication today with Wi-Fi is microwave based, so 2.4 gigahertz or 5.8 gigahertz. And also these frequencies, actually up to 10 gigahertz, they are frequencies which can pass through the weather of the atmosphere, through clouds and rains. And that's what makes them so interesting for space-based solar power. So we can actually beam microwave energy 24 hours at all weather conditions. And now you may think, okay, if this is arriving, what happens? Does my brain heat up or whatever? No, it's actually the beam is so wide from that distance that actually the power which is arriving per square meter is very, very low. The other thing is you have to build very big antennas to receive the energy. So we're talking about 6 kilometer diameter rectennas, but the rectennas, they are basically a mesh of wires with rectifying diodes. And 6 kilometers may sound big, but actually, if you look at the charcoal mining plants in Germany, they pretty much have this dimension. So you could establish them over these coal mining places, or even you could build them over agricultural land. So there are many options. Obviously, this needs to be deeper explored. And now also Europe, ESA, with their Solaris program, they actually set up the first step to go deeper into this technology and explore it. But it's a quite promising technology.
Yeah. Just one other thing. The last September in Munich, Airbus organized the first European large-scale demonstration of wireless power transmission, and they did it inside a hall, 36 meters, and they were cooling a refrigerator full of beer with it, but they proved that you could actually beam energy over this distance. So the next step is more demonstrations like this on Earth, maybe kilometer size. And the idea behind these kind of demonstrations is to interest the energy industry. They want to see something work. So it's a long ways to go from 36 meters to 36,000 kilometers, but it's being looked at right now. And there's 2 feasibility studies that have just been launched by the European Space Agency to look at the technical aspects of this technology, and they're going to be looking at the environmental aspects too in future studies.
Wow, thank you, Bernard. You have also some questions. I saw you thinking about something. I would like to give you the floor to add your questions.
Thank you. Yeah, first a comment. I mean, very comprehensive talks with a different aspect, and it's a very interdisciplinary topic. And you have started to tackle it, but you mentioned it's a big endeavor, so you will really need to get a strong team helping, and we would be happy to help. And also, I would say the visualization are very inspiring. They are almost exact. There is one little for you, some of you that are part of Moon Village Association, and we are going to organize International Moon Day, looking at the moon. You will have to figure out that the way you see the face of the moon on your movie is backward. So you show the moon illuminated from gibbous to first quarter to crescent. If you will go with time, it's a other direction. But maybe it's an aesthetic.
No, Bernhard, I knew you were going to say that because you're very expert. You know very exactly how the moon looks. But honestly, we have to admit that the moon in our model is not, as you noticed, the precise model.
Yeah, but I mean, it's a beautiful representation. It's virtual. You can see a bit of the far side of the moon because You recognize a bit beyond, you know, in the picture behind Arthur, you can see Mare Crisium, and you can even say Mare Moscoviense, which is on the far side. And of course, we are all lovers of the geography of the moon. But it's nice that you challenge us to be critical. But on the other hand, okay, it's like artistic license. Now I have a serious question. Clearly it's a big endeavor, and so how can we help to make it step by step? And so what could be a precursor demonstration mission in even a short time scale, in the time scale of some of these commercial lunar payload service mission that we could think of and would already help to energize some of stakeholders and already test some of the technology and start to make some progress to convince around. So what could be a precursor demonstration mission?
Well, we have two things that we're cooking on. We gave a presentation in Japan 2 weeks ago about our low Earth orbit platform, and that could be a demonstration platform that could be built. Okay, that's like a small space station, but because it could be launched from Kourou, you could have different SPS locations around the planet that could actually, you know, try out the technology. Okay, that's a little bit on the large scale, but also today we're in a consortium of companies, and we're making a bid for a European, an EU call for space-based solar power. And what we're working with these people in Estonia and some people from Poland who want to actually test their technology in space. So we're already conceiving a demonstrator where the technology that we showed here can actually be tested in space, and that's a step that we're looking at right now.
Okay, so if you could have a little comment about also lunatic fact. You mentioned pyrite.
Yeah.
Pyrite, that's iron S2, so that's sulfur. Sulfur, there is very little amount. It's 0.2% of sulfur on the moon. So be careful about pyrite.
There's actually triolite on the moon. Triolite is quite plentiful, and you can break up triolite to get the extra sulfur element you need to make the pyrite. That's kind of the approach of the.
Yeah, but 0.2% is very little, huh? But,
I know, but actually, at the end of the day, we estimated. Yeah. I must say, we estimated the whole transportation capacity from this 2% up, because obviously an SPS 80% of its weight is the solar panels and the pyrite, and we actually back estimated from this 2% how much regolith do we need to mine to get that out, and how much other stuff. So we looked into that, and you're absolutely correct. I just wanted to add, maybe for demonstrator, because I understood you're looking what could we do near future on the moon, and I think that the two things. I think one real necessity, and I'm astonished this is not yet existing. I think we really would have to establish kind of an open source material laboratory platform on the moon, where universities from all over the world, they can buy laboratory time, a kind of robotic laboratory where you can drill, you can dig, you can heat your material, you can place it there, you can melt it, and I think this is urgently needed, that we
and this part of the current roadmap, a robotic village, resource extraction. So clearly this is going to make progress, but also how we can use basalt itself, and maybe not so much the sulfur. Okay, you have to explore everything, but the basalt silicates, I mean, for solar panels, that could be also very, very good. My last question, also a bit of technical nature. So how critical is the lunar space elevator in this architecture? So do you have also an alternative? I mean, clearly this would be holy grail, but how critical is it? And what's the weight of it?
Okay, the weight of the initial elevator, as estimated by Charles Radley and Marshall Eubanks, would be 45 tons. Okay, that's
Oh.
the initial one. And this
Wow.
would set up the first line. So this could be delivered by one heavy lift launch system.
Okay.
Now, how valuable is it? Well, if that could happen, it would be a fantastic asset. And whoever runs that would be in an advantageous position. So it should be a multinational endeavor anyway, just to keep it geopolitically neutral. But on the other hand, we looked at the mass driver. This is the classical way of getting mass off of Earth. But we, as Andreas pointed out in his talk, that by using gravity for the manufacturing process is a big advantage because we know how that works.
Yeah.
Trying to take the raw material and send it into orbit and there do all the processing and beneficiation and fabrication is a whole nother dimension. So we tried to find technologies that practically exist today that we could actually extrapolate into the lunar system. And so that's why we're using those things. But the lunar space elevator is a fantastic thing because
If it works,
get
it
the
would be
material
beautiful.
off of it. It does it in a very gentle way. Okay, you don't have a lot of landing. And if it could happen, it would be fantastic. And actually, we have an idea how to expand it. We would have other strands coming down from, let's say, a hub at about 3,000 kilometers above. So we could actually have other things happening there. And there's a lot of aspects of other alternative. Yeah, like I said, mass driver. Nobody's really looked at how you catch the stuff that well, and they've talked about it, but it's a big issue to catch the material, and then you have to do all of the processing and manufacturing with raw material in orbit.
So a lot of beautiful technical, economical, human challenge, but clearly, as you know, 2 years ago at the Space Renaissance Congress, we put space-based solar power as one of our action plan to make progress. So clearly, in Space Renaissance, we are ready to help you from all those aspects, and support you in this endeavor. Thank you very much.
Well, thank you for letting us present. It's the first public presentation of our idea since we just gave our final report just a few weeks ago at ESTEC, and so we're just now in the process of getting out. So this is the first opportunity. Thank you very much. And by the way, the videos are really were a pull for the whole development of the study. So when we had an idea, we turned it into a visualization. So the videos were not just decoration; they were really a way to think through the thing. So everything we showed in the videos, we thought about quite a bit technically that they could work or not, And our final study was 275 pages of documentation. So we really actually looked deeply into the technical aspects and wrote about it.
But with this beautiful visual, we should make movie with an early movie.
Yes.
Absolutely, yeah.
Yes,
that's on our wish list.
It's actually we're planning.
Yes,
I
like this very much
something
too.
to ask. Yeah, thank you. So Bernard stole one of my questions about the lunar elevator, so we save time because I was trying to understand more about that. But my other consideration is about the Kraft-Erike plan, the lunar industrialization and settlement, the birth of the polyglobal civilization, as he called in one of his most famous papers, on which I made a lecture 2 years ago at our Berlin festival. And unfortunately, the crash of my hard disk, I lost a lot of things, including that presentation, but the video is still there. So I was able to retrieve the video and to see that Kraft-Erike was thinking about 5 development stages for the lunar economy. So the first stages was the synoptic prospecting for mineralogical provinces and candidate-based sites. And the second, stage 2, was establishes a circumlunar space station, the moon ferry, and automated laboratories and pilot facilities, including an oxygen extraction plant on the surface. The third stage establishes a first-generation nuclear-powered central lunar processing complex. And the first stage of large-scale industrial production begin. The fourth stage diversifies productivity by adding feeder stations in more distant metallogenic provinces. And the last stage established Selenopolis, that is the urbanization of the moon. So I think the objective, the goals of the Kraft-Therike planning was a little bit different from what we are discussing today. It was thinking about living on the moon, to establish a population on the moon, and developing an industry on the moon to produce a lot of products that come from the lunar minerals, regolith and not only, so metallogenic things, etc. I would like to understand if you made some kind of comparison between the Kraft-Therike plan and your plan, that in the last slide where the timing from now to 2050 was shown, no, it's a kind of Gantt diagram with all the activities and what come first and what come later, and so on. So it would be interesting to understand in the current planning how much is the impact of robotics and artificial intelligence, first thing. So what could be the difference in timing in realizing? Because I think maybe the stage one, the synoptic perspective is already done, because since many years we are observing the lunar surface, they identified where the ice is in the poles, and where are the most promising areas for the point of view of mining and all these kind of things. So yeah, I think what Kraft-Therike thought was a little bit different, because it didn't think about beaming energy from the moon to Earth. It was thinking about developing lunar energy to develop industrial development on the moon, and to allow people to live there, and to build a self-sustaining economy, lunar self-sustaining economy. I think that nowadays we are thinking in a more colonialist way. I mean, go there, take the resources, bring back to home.
Well,
this is a little bit, I think, different from the Kraft-Therike goal to expand the civilization.
Well,
so yeah, okay.
Yeah, no, may I answer also on that? Because it's very interesting. I would say, if you talk about industrialization of the moon, I think Kraft-Therike's perspective as a wonderful visionary, space visionary, in his time has been industry is manpower. And if you look back to the last 2 decades, the development of robotics, artificial intelligence, and what so on, industry is probably not manpower anymore. And although I'm an architect and I should do habitats for people wherever in space it happens, I would say still that the moon is a pretty harsh mistress. And at least my philosophy is kind of more Yuri Gagarin. Let's safeguard the beauty of our planet, and let's use the resources we have in space to safeguard this. And so what we looked at, it really how to use robotics to make something possible which would be very dangerous and challenging for people. And so our idea is not to make new colonies on the moon, but to use our robotics and automation skills to put the industrial uses we have on Earth now, maybe more of them on the moon, and to produce in space what we need in space, basically satellites, and to reduce launches. So it's a little a different philosophical conception that at the time Kraft-Therike had, or Gerard O'Neill with the space colonies.
Yeah, Yeah, generally, yes.
So
Sorry, but
Yeah.
when I use the word colonialist, I mean the old concept. The old concept was to send military in that time in the centuries of the Earth colonialists, to send them weaponized task forces to take resources and bring them back home, to take resources at the low or zero cost and sell them at home at high price. That was what I call the colonialism in the ancient time. So I don't use it to mean to make colonies over there, because that thing I call settlement. That's different concept from colonies. Okay, but I think using robots and artificial intelligence, maybe we are losing the ultimate scope of space exploration. And that is the expansion of the civilization. So if we don't go there, we send robots to build things to be used on Earth. I'm afraid our civilization will not grow anymore, because we don't have the plan of Jeff Bezos, that I like very much, is to move industry outside and to transform Earth in a beautiful garden, naturalistic garden. Yeah, but together with the machines. We have to send people to live in space. Otherwise, everything from a philosophical point of view, everything will be useless, because we will not have the growth of humanity.
Yeah, Adriano, in our
humanity closed in a closed world at the end. Yeah. The concept will be opposite to the Krafft-Erike concept of an open world. Yeah, this is my opinion. Okay.
In my first slide, almost in the thing, I told you the lunar power station is a habitable facility. It has a habitat for people. We actually include people in this thing. And actually, if it's shown to be feasible, this could actually be a prototype for the word colonies or space settlements that could be built out of the same thing. They would be self-supporting with their own energy system. So it's actually a manned facility. And Erica didn't have the energy and the climate crisis at his time. I think he would be totally in line with what we're talking about.
He saw the beginning, and he was he was polemizing with the green movement, because in
1970. People were still using a lot of fossil fuels, and nobody thought they would be finite. I think today, because one of his most famous quotes, as you know, from our space option concept that Erica wrote, he goes, "While civilization is more than a high material living standard, it is nevertheless based on material abundance. It does not thrive in abject poverty or in an atmosphere of resignation and hopelessness. Therefore, the end objectives of solar system exploration are social objectives in the sense that they relate to or dictated by present and future human needs. And a human need that has become very crystal in the last years is, how do we solve the climate and energy crises that we're faced with today? And this is it. If we don't solve that, there's not going to be a space program.
Yes.
So that's why energy becomes the driver for lunar development. And it's just that once you have infrastructure
But also let's think that if the Bezos plan is realized and we move the big industry development outside, the demand for energy on Earth will be only the private citizens' demand. So it will be ideally halved with respect to the prospect you made, the forecasts of the energy consumption.
These are not my forecasts. These are forecasts by the International Energy Agency and what they suspect that has to be done. We need to find a clean supply of energy here, no matter how it happens. This becomes an economic driver. It's a business case for going to the moon. Sending a woman to the moon or sending a person of color, this is a nice thing to do. Doing some more exploration is very nice to do, but it's not a business case. You have to, and Bezos is in that line. Bezos is going in that line. It's very true. But the market on the Earth for energy is just extremely big. It's the biggest market in the world, and it's actually it involves everything that society's connected with, and that's why we think space could play a major role here. And apparently, other people in the space community, like at ESA right now, think in the same way, because they're looking for a solution to solving the climate crisis and the energy dilemma.
And also to add one thing,
sure.
one thing doesn't exclude the other. If we do automation, I mean, in the 70s, we thought we need staff of a couple of thousand of astronauts assemble big beams in space to build a power satellite. Now we can use robots. So the people, they can do other things. They can explore. They can use, and that's going through the whole human history, that with machines, we automate things. And so people have more time to do other things, like what is really in human nature, which is exploration. And I think one doesn't exclude the other.
No, okay, yeah, sure. Well, however, a very interesting presentation. I didn't make my compliments, but it's really, I think, one of the most interesting and detailed, because you don't only show concept, but you also give numbers. You give some kind of economic forecast and business plan and so on. And I think this is important, because we cannot go ahead just thinking about science fiction solutions without saying we can do it in 10 years, we can do it in 15 years with this money and so on. So this is essential if we want to be serious in our ideas of expansion into outer space. Okay. Let me make just one short advertisement. You know that we are
I want to say this.
We are taking on our initiative for N18 SDG, focused on space development, to be added to the 17 SDGs of the 2030 United Nations agenda. This action already saw two important milestones. The first one was the presentation at COPWAS in Vienna, the 5th of June, of our proposal. It was presented by Carlton Johnson of the NSS, and on behalf of NSS, the SRI, and other 37 organizations that including some of the biggest. So the NSS, the National Space Society, you said the Mars Society, the Lifeboat Foundation, the Human Space Program of Frank White, the Beyond the Earth Institute of Stephen Wolf, and the Space Tourism Society, and many others. So this is a very important initiative. We made a first public meeting the 12th of June, so past Monday. And we will be doing a panel the 15th of September at the United Nations General Assembly 78 in New York, presenting this initiative. And we hope at that point we will maybe have at least one state party. That means one of the nations that are subscribed to the United Nations that will endorse this proposal. So the 18 SDG is, of course, made to bring space as a key factor of sustainability for Earth and for civilian space development. So both technologies of space for Earth and technologies to go outside and start living and working outside. So this is the philosophy. We invite everybody to sign our petition and to add space policy, space advocacy organization to the coalition. I will post now in the chat the link where we can sign. And okay, I hope everybody will join us and support
Yes.
this initiative.
Let's go, space for all.
Yes,
Yes,
space for all. Yeah, I would like to ask you to put it in the chat, and
Yes.
I would like to take this opportunity to thank you, Arthur Booth and Andreas Vogler, for this really, really amazing lecture and this, all the visualization, and it was really, really interesting. And can you put it in the chat from YouTube, Adriano? You put it here in the chat in the
Yes, I'm doing that.
yeah. And I also would like to thank you, our audience, for joining us. And I would like to invite you to our next webinar. It's on the 3rd of July. Our guest will be very young and very successful, wonderful scientist, Pranvera Hiseni. And she will talk about exploring hydrated asteroids via reflections, spectroscopy, and about outreach of Kosovo. She has reached that she wanted to bring on her goal science and astronomy to Kosovo, and now they are constructing an science center with a planetarium in Kosovo, and so she's really amazing, and with her 28 years she has reached much more than other scientists, other people in their entire life. So I admire her, and yeah, I am humble for this young woman. So I would like to invite you to join us on 3rd of July. Bernard, you have a comment? Give it to me.
Yes, also because it's a time of the announcement. What is next? So clearly we have seen energy. It's a big topic. It's not the only one. So of course we should think that there are many other issues, that we have 17 goals. We have the 18 sustainable development goals, but there is energy, there is water, there is peace on Earth, there is knowledge. So all of those are areas where space, and in particular, if we are together working, space for all, where we can make a contribution and advance also benefit to society. Now, a little announcement, short term. So this week we have the Air and Space Salon in Le Bourget. So it was open today in Le Bourget near Paris. So with a lot of political presidents and so on visiting various space stands. Then tomorrow there will be a dedicated day on exploration. I will attend. There will be one day on transportation as well that will attend. And I've been invited to join a panel actually by a consortium of industries that are promoting the exploration of the moon. They are called Euro to Moon. And we are also engaging some activities involving and helping this industry to get prepared for an ambitious exploration program in Europe and in the world. And so they work at the level of agencies, at the level of politics, and also level of the public. And so clearly we have all to help there. Also, the last week of June, there will be the European Lunar Symposium. So it's another survey meeting. So actually, which will be hosted in Padova, in beautiful city of Padova, with whom we celebrated last year 800 years of their universities. Space Renaissance will be present there. We will present a number of activities in Padova. Also, some of the activities of our young professionals that are also developing analog astronaut campaign and research. On this point, we had also very interesting premiere, as we have just built a portable habitat for astronauts with some inflatables. So Andreas, you inspired us 20 years ago. Now we have done it also in our terrestrial version of an Exospace Hub Express, a small habitat that is available in Italy. Space Renaissance is a partner of this project, but also we are going to move it from place to place and make it available to universities, to industry, to communities to do research, to train analog astronauts. So the civilian development generation, we train them, but also to train space entrepreneurs to know more about space. And it will be put in France after Italy, and also we will have it from November in the Netherlands, where we will deploy it just across ESTEC as a kind of test bench where we can integrate some of the technology. So maybe if you have some idea of a demonstrator of extraction of resources or making some miniature solar panels, we could try to integrate that in a short term on the terrestrial version.
Just an idea came to my mind now. It would be interesting to take it to the orbit in Fino Mornasco, in the premises of Fino Mornasco, the orbit SPA. That is where is our site, our legal site of Space Renaissance International is there.
Oh, okay, so let's do
premises of the orbit.
So let's do a symbol and a nice party as well. Yes, exactly.
Yeah, it could be.
Let's think of that.
We have to think about organizing.
Okay. Excellent. And so, by the way, on those topics, we are also on the various topics that are part of our plan of action that we determined in our Congress 2 years ago. Space-based solar power is one, but there are various others. We have really a good community of volunteers in Space Renaissance, but we would like also to help the volunteers to develop some tasks which are useful, some of the projects. So if there are some volunteers, for instance, that would like to help really in concrete on the space-based solar power project, we would like to enhance that. And I'm looking also at a scheme where we can make available some, Space Renaissance grants. We have a Medici fund, but we have also other source of funding. The Eurospace Lab Academy is now also providing a research fund for some of the young professionals. And we are going to bring 10 of them on the Vulcano Island in the Aeolian Island, the first 10 days of July, where they will go in the field, test some instrument with the German Aerospace Center, with the University of Bremen. So we are going to train them to prepare themselves for the moon base, where they will have later to produce all these solar panels and the space elevator. But we start step by step. So also for follow-up activities, note that we are organizing also this week with the Eurospace Hub, our partner of Space Renaissance. We are organizing training online every day, European time at 5 o'clock. You have a dedicated training on space business, on space diplomacy, on collaboration tools, on social media. So this is open to our partners. So please also make that known, in particular to some of those that want to contribute to our activities. So you see a very active month of June with a great startup with your presentation today, which is also very inspiring. Thank you so much.
Thank you, Bernard, for all these activities, for doing this, because it's really great work what you are doing. And also Adriano for SRI.
Space Renaissance community. Yeah, but that's all.
Yes, but it has to be mentioned once.
Yes.
And I would like to thank you all for this interesting evening. It was a really nice evening, a pleasure for me to moderate this evening. And I hope to see you in 2 weeks and wish you a nice week. Okay. Yes. And then successful June. Okay. Bye.
Thank you.
Go Space Power. Go Space
Ad Astra.
Ad Astra.